Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thanks be to all for giving us health and pleasure. On this occasion, I would like to thank the supervisor and examiner. Thank you for taking the time as a guide and examiner for my final project presentation. I will introduce myself first. My name is Zulaika Nurrochmah with NRP 0616040025 from the Design and Manufacturing Engineering Study Program, Department of Ship Engineering. Here, I will present my final project with the title, Design of Bollard Construction with AH32 grade material on hospital at ship, PT PAL, Indonesia. Okay, I will explain the background. Hospital at ship is one type of ship that is used for health assistance as a floating hospital. Ship equipment system also need to be considered when floating ship. One of them is bollard. Bollard is a tool to tie a mooring rope to the ship. The design of the bollard and the material affect the stress on the bollard. So we need a more efficient construction strength and bollard design. Therefore, in this final project, a bollard design will be carried out on the hospital edge ship with AH32 grade material, which have a higher yield stress without reducing the strength needed. After designing, the next step, which is to analyze the strength of the bollard to find out whether the structural response due to material replacement is in accordance with the criteria. Next, I will explain the research problem. One, how is the stress and safety factor analysis that occurs on the existing bollard with grade A material? Two, what is the bollard design that is more suitable in terms of strength, weight, and price for hospital at ship with the AH32 grade material? Three, what is the maximum stress value that occurs in bollard construction with the AH32 grade material replacement? Four, what is the result of the weight value obtained due to the replacement of AH32 grade material? Five, how a comparison of the existing bollard design with AH32 grade material? Next, the research objective. One, knowing the analysis of the maximum stress value and the safety factor that occurs in existing bollard construction with grade A material. Two, designing a bollard that is more suitable in terms of strength, weight, and price on the hospital at ship with AH32 grade material. Three, knowing the maximum stress value that occurs in bollard construction with AH32 grade material replacement. Four, knowing the result of the weight value obtained due to AH32 grade material replacement. Five, knowing the comparison of existing bollard design with the AH32 grade material. Next, scope of problems. One, modeling will be analyzed using Fusion 360 software. Two, the type of bollard study is a double bollard type with a capacity of 60 tons. Three, doesn't take into the cost of the bollard structure fabrication process. Four, the effect of welding and vibration of the system on the bollard structure is neglected. Five, stability analysis is not carried out. Six, high and low tides of seawater are ignored. Seven, the loading conditions are carried out when moored at the dock. Eight, environmental data is used in Space Marang Dock Water Area, PT PAL, Indonesia. Next, flowchart. Start from literature study. Next, identification of problem, and then data collections with includes ship data, bollard data, and environmental data in PT PAL, Indonesia. Next, force calculation on bollard. Next, bollard modeling using Fusion 360 software. Next, bollard construction stress analysis with Fusion 360 software. The actual stress must be less than the permission stress so that in making bollard it is declared safe. Next, safety factor analysis of bollard construction with Fusion 360 software. And the last is conclusions. Next, in this chapter, the analysis and discussion of the final project of the bollard design will be discussed. In this final project, a bollard design will be carried out on the PT PAL Indonesia Hospital at ship. The ship has 9 pieces of bollard, which is a double bollard type and grade A material, and has the following general dimensions. The first calculation of force due to current can be calculated with the following equations. So that the current force that occurs is 51,681 Newton. Next is the force due to the wind. First, the longitudinal force if the wind comes from the direction of the bow can be calculated by the following formula. So we get a wind force of 68,143 Newton. Second, the longitudinal force if the wind comes from the stern direction can be calculated by the following formula. So we get a wind force of 81,127 Newton. Third, the longitudinal force if the wind comes from the side can be calculated by the following formula. So we get a wind force of 178,495 Newton. Next is forward loading. After calculating the design P, then calculate the design force. So we get a design force is 367,875 Newton. Next, bending stress with the result 38.9 megapascal. Next, permit stress with the result 140.7 Newton per millimeter square. Next, for the list of needs, you can read in the table for the needs, descriptions, and person in charge. Next, we discuss the design of the pollard concept. This pollard existing has an amplifier construction on the bed plate and has a permit stress of 140.7 megapascal. Design concept 1 has a two body tubes and bed plate sides that are parallel to the pollard tubes. Design pollard concept 2 includes a quick release hook type and has an automatic hook system that is controlled by foot pedals. Design pollard concept 3 includes a winch pollard type and has an automatic system that can spin pulling mooring rope. According to the dimensions, you can see the table, the difference of the dimension of each concept. Okay, next we discuss the strength analysis. In the analysis of the existing pollard, the stress is 39.15 megapascal. Pollard analysis of concept 1 found a stress of 69.4 megapascal. In the pollard analysis of concept 2 or quick release hook, the stress is 46.65 megapascal. Pollard analysis on concept 3 or winch pollard obtains stress of 52.68 megapascal. All designs that have been done can be said to be safe because stress analysis doesn't exceed the permit stress. For comparison of the result of the analysis of safety factors, displacement, strain, and stress can be seen in the following table. Next, we discuss weight analysis. In the existing pollard, the analysis result obtained a weight of 943.2 kg. In pollard concept 1, the analysis result obtained a weight of 893.3 kg. In pollard concept 2 or quick release hook, the analysis result obtained a weight of 1,379 kg. And in pollard concept 3 or winch pollard, the analysis result obtained a weight of 1,204 kg. Next, we discuss cost. The lowest cost is existing pollard, and the high cost is pollard concept 2. Next, we discuss about concept selection. The analytical hierarchy process method is a method that will be applied to determine the selected pollard by comparing four alternative pollards. Each pollard in each criterion is calculated by step according to the data that has been obtained so as to produce a value as shown in the following table. And the final result of the implementation and testing of the best pollard selection system is the concept 3 pollard or winch pollard. Next, we discuss about selected pollard. This is the picture of selected pollard. After designing a pollard, we also need to calculate the motor power requirements. After doing the calculation, we get pulled on pollard winch rope with the result 4,833 kg. Rotation of the pollard winch roller shaft with result 7.64 rpm. Electric motor rotation is 1,200 rpm. Winning torque moment with the result 8.55 kg mass. And pollard winch motor power with the result 10.68 kilowatt. The next is the discussion about pollard comparisons. The existing pollard is a double pollard type that and used girth material, includes double pollard type and has reinforcement construction on the bed plate. Next is winch pollard. The performance of the winch pollard is that the body pollard can spin and pull the rope when the ship is mooring is with just one person operating equipped with speed control and controlled by foot pedal. On the bed plate, there is a room for hydraulic motor replacement for 11 kilowatt. For pollard comparison can be seen in the following table. Next, we discuss the advantage of winch pollard, which are: 1. The operation is carried out by only one person. 2. Automatic moor system. The pollard party can spin and pull the rope when the ship will moor. 3. It's easier and save times. 4. Optimal and safe control by using foot pedals. 5. There is a speed control and low noise during operations. Okay, and the last is conclusion and recommendation. 1. The result of the analysis of strength of existing bollard are 39.15 megapascal. Bollard concept 1 is 69.4 megapascal. Concept 2 is 46.65 megapascal. And concept 3 or selected bollard is 52.68 megapascal. That is can be concluded that the design of the bollard design is still said to be safe to operate if the maximum stress doesn't exceed the allowable stress 140.7 megapascal. Okay. Second, the result of the safety factor in the existing bollard construction is 6.002. Concept 1 is 4.539. Concept 2 is 4.437. And concept 3 is 5.98. This can be concluded that the structure with this system is still said to be safe according to the safety standards set by EPS. 3. The design of the bollard uses the Fusion 360 software and is carried out according to the G standard of the existing bollard of the hospital vessel by taking into account the strength, function, weight, and cost so that the concept of bollard 1, 2, 3 has the appropriate analysis and criteria. 4. From the weight analysis result obtained, the selected bollard or winch bollard can be reduced the ship load by 1,264.8 kg. And the last, from the design of the three concepts carried out, concept 3 was chosen in terms of its operation of the bollard compared to two other concepts. The existing bollard is a double bollard type and its operation is still using a manual system, while the design of the selected bollard is a double bollard type and has an automatic mooring system with a motor power of 11 kilowatt, making it easier when the ship is mooring on the dock. Next, the recommendations. 1. Analyzing the strength of the structure on the foundation deck that contains bollard. 2. Planning an automatic pull and pull system so that it knows the sensor programming when commanding the motor to wind up or extend the mooring rope. Okay, thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.